we got through it. It's all good. Mitch was here, actually. I had Mitch helping me this morning after we got hacked, but we're all good.
Well, I'm glad to be here.
Fine.
I'm
yep.
glad for the quick recovery.
Absolutely. And welcome, Donald. I'm going to turn the stage over to you.
All right, let me see what I can do here. I'm going to share a screen. There we go. You should be seeing the presentation. I'm going to talk about creating custom mounts for motors and solenoids, something I've been doing a lot of for the past 6 months to create my drum robot. It's still really TBD on the name for my drum robot, but it's a 7-foot tall drum machine that I've created. And part of that process, the thing that I didn't really find a lot of great resources on early on was figuring out how to mount motors and solenoids to knock into drums to create the machine. So if anyone else is kind of going through that or think that they're going to be going through that, this should be a good presentation for you. I'm by no means an expert in this. Like I said, I've really been only at it for 6 months now. So take everything with a grain of salt, but hopefully for beginners, this will help give you some resources you might not have before. I'm going to talk about some existing designs that are out there for mounting motors and solenoids, some techniques for modifying or creating new designs, modifying existing designs or creating new ones, some of the useful hardware I've come across, and just some general tips for either 3D printing or laser cutting or making them from scrap wood or whatever you got to do. Quick about who I am. I'm Donald Bell. I go under Chachi Jones for my music that I've been making for a long time. A lot of that's usually electronic music. I host a weekly show called Maker Update on the DigiKey channel. I'm a staff writer for Tinkercad on the Tinkercad blog for 3 or 4 years. I do tool reviews of cool tools. I used to be a project editor at Make Magazine, and I enjoy making robots, cocktail machines, and music. Now, talking about the specific types of solenoids and motors I've been using, based on, sorry, my snare drum's rattling, based on a few other projects, I've kind of hit upon these two as being the most useful motors and solenoids that you can get your hands on. So I'm going to be talking about Adafruit's 12-volt, what they call their large push-pull solenoid, and a type of motor that's really common, especially in power tools. You can find them on eBay for under $5 typically, called the Mabuchi 555 DC brush motor. Some benefits of kind of why I'm using a mix of both in my project. Solenoids are great, but they have a relatively short throw. You can actually, have them knock directly into things because they have a little mechanism that's great for just knocking right into the thing you want to make sound with. They're relatively easy to mount. They are a little clicky built into the design, which can be useful in some instances, and sometimes when you don't want that click with the thing that you're shaking or doing, it can be annoying. And generally, unless you get up to higher voltages, from what I found, they're relatively low impact. So if you're trying to make a loud sound, they might not be so good unless you do a lot of work to adapt these or you get into higher voltages. Motors, on the other hand, depending on what you're using, but just talking about the Mabuchi one that I've been using, they have kind of a higher torque. They're reversible, so if you want them to hit things and by reversing the polarity on the motor, you can have it hit 2 different things in 2 different directions. They're a quiet operation. They don't have any built-in noise that's inherent to the design, and they have a longer throw. Really, you got entire 360 degrees of momentum you can pull from before it hits the thing you want to hit, and that can be helpful for getting a louder sound out of things. The drawback is that you really need to figure out how to attach a beater of some sort, or a drumstick or something, to the end of this thing. But we'll talk about that soon. Some existing designs that are out there. German company or a guy, Johannes, out in Berlin, has a company called Data Machines. They've been doing a kind of ready-to-go kit for solenoid drum machines for a while now, and he's got a great GitHub page that has a lot of laser cut designs for adapting solenoids. some of them. This is kind of my remix version of one of those. It's like a standalone little deal, like that's pictured there. But there's a lot of other great ones that can mount onto boom arms and mic clamps and things like that. Worth exploring. I also got a lot of use out of the Adafruit designs that are out there from the Ruiz brothers and Liz Clark. Some of them are a little more built for low impact of kind of desktop kind of knocking into things, but they can be they're useful to tinker around with, and you can, some of the mounts in particular, you can easily remix into other projects. I have a link to this presentation, by the way. Hopefully we can include in the notes here so that you can get at these links and discover things on your own. Real quick, the anatomy, at least of this 12-volt solenoid. There are 4 threaded M3 metric holes on one side of the solenoid. Those are the key little points here for mounting this on stuff. Plus you get 1 non-threaded hole here for, you know, having this work in some kind of linkage design. That's on the shaft that goes up and down. Some of the remix projects I've done for those, for solenoids in particular, there's one here on the left that is pretty useful for mounting directly onto round objects, or in my case, some wood blocks. It's the way I've kind of adapted it is useful for zip tying onto stuff. There's kind of extra holes here for zip ties. I'll talk about zip ties in a second. And then the other one is a wingman mount. And the links that are on both of these go to Tinkercad designs that anyone can see and copy and tinker with on their own and adapt however they see fit. The motors, the anatomy of this Mabuchi motor in particular, you've got 2 threaded holes on the motor side that are useful for attaching this to stuff. Again, they're the M3 bolts. And you also have the shaft here, which is kind of a D-shaped shaft that has a flat spot on one side of the shaft. It's 3.17 millimeters wide diameter, and you can find little adapter plates for these, and I'll link those in a moment. These are some of the mounts I've remixed off of the Mabuchi motor. For all this popularity, you can find a lot of different fittings for this that are already out there on places like Thingiverse. One that I found was by this guy, Rene76. I tweaked it so that it had a little stop for a stick to return back to it, and you can kind of see it in the bottom right-hand corner there. So that when the drumstick goes down to hit the item you're trying to hit, when it returns, and there's a spring there to return the stick back into its original position, it's got a little stop block so that it can, you know, not just travel wildly back and forth. We'll also link to the mallet holder, which is the part that goes onto the motor shaft and holds the stick and then attaches to the mounting plate. And I'll show those on the next slide. Some of the additional hardware I've had to use in order to make these designs work. In the center there, you can see the D-shaft metal mounting plates that are used for mounting the stick to the shaft of the motor. They're relatively inexpensive. These are, I think, all Amazon links. There's metric bolts here for the M3 things. There's lock nuts. A lot of the metric bolt kits come with kind of crappy nuts that will, in the process of things shaking around, will go right off your bolts. So the lock nuts are pretty critical for keeping things together. A spring assortment can be useful, specifically for the design, the motor design, for having the stick return back to its position. And I think the coolest thing that I found are these, you can see the black rim clamp design there. These are mic holders specifically that attach to the rims of drums. So if you're trying to adapt a motor or solenoid or something that's going to be knocking into a conventional drum, a snare drum, a tom, these clamps, I think they're like $10 a clamp. not super cheap, but cheap enough where replicating its features it's more, what am I trying to say? It's a lot more useful to just go out and buy it. It has been for me. And they've been useful for things like this, where you've got, I'll show it off. Let me stop my share here real quick. Not new share, but stop sharing. Here you go. So here it is. You can kind of see how it clamps onto the drum down here. And then you've got your beater here, the motor mount. And there's a lot of zip ties involved. I'll talk about zip ties in a second. But this is the most useful and loudest design I've been able to come up with so far. And being able to mount the motor to the bracket and have this bracket easily mount to any kind of rim style conventional drum has been super useful so far. All right, back into it. All right, mounting holes in particular. We talked about the anatomy of both the motor and the solenoids and how each of them have places for you to thread or threaded holes for mounting to metric bolts. A lot of times, depending on what you want to do, the trickiest part is figuring out how to replicate those mounting holes to a design. And so in Tinkercad, if I have time, I could even show this off later on if people really want to know. In Tinkercad, you can drop some, 4mm sized holes into your design, and then bring in the ruler. And Tinkercad's a free program, so there's no price in just messing around with it. Bring in the ruler tool and use that to space out those two holes exactly what the distance is. And now on the solenoids, it's about 17mm or 18mm. I think that's what I have in the picture here. 18mm between the centers of the two holes. Once you have that, you can save even that hole pattern as an object that you can bring into any other design and reference pretty easily. And that's useful for 3D printing, but it's also useful. You can use your designs. You can export them in something that you can send to a laser cutter. Another trick that's useful for designing mounting plates, and these are from the data machines one you can see in the bottom left corner, is to have slots that you can adjust the position of the solenoid or motor as you need to make changes on the fly to bring something in or out a little bit further from the thing you're trying to hit. Sometimes having the ability to dial it in or in the process of something rattling out of place to kind of put it back to where you want it is invaluable, especially in the early stages of coming up with the design. Now, zip ties have been my go-to, especially for prototyping. I think if you're doing something that's an installation piece or something that's maybe lower impact, going to the trouble of creating exactly the right mounting plates that are rigid may have some benefit, but as I say in this first line here, embracing failure, knowing that these things are going to rattle out of place, or that you want to be able to fix them up differently, or that something's going to fall apart. Zip ties are a really inexpensive way to repair a thing. And if you design for zip ties, you can save yourself a lot of headache. Especially if this is something you're going to gig with or take out to an event, knowing that you can fix the problem with the zip tie and you've already designed for that ahead of time can be a real advantage compared to having to keep a bolt assortment with you or having to run out to a hardware store. So a lot of the remixing I've done of other designs, some of that just comes down to adding loops or the tube shape in Tinkercad to some of the parts here so that you can easily thread zip ties into the design and be able to have that hug the drum or percussion that you're trying to strike. The other part of designing for zip ties for me has been the tension on the solenoid or motor. I'll take this out of share mode again just to show this. So up top here, I've got the holes for zip tying this down to a thing. But I also have the zip tie here that's just keeping the tension on these wings so that these don't over time tend to spread apart as the compression that's coming down from the zip ties would have them do. So some of the times the zip ties are about tying it to the thing you want to strike, and sometimes it's just about keeping your design together. This is another one. This is the motor mount. There's zip ties that are keeping this motor mount tied to the clamp, but there's also zip ties that are keeping compression on the structure for the motor mount against the cylinder of the motor. So designing for zip ties is both having a place for it to attach to the drum you want, but also having ways to keep your motor mounted with not just your bolts, but with some kind of compression to kind of keep everything snug. Because the nature of these things is that they're vibrating all the time or striking against things, and they're gonna shift. So back into it. Some 3D printing tips, just from my own experience over these past 6 months, I found that for the rougher applications, PETG filament has been a little bit more resilient and tends to crack less than the PLA that's a little bit more common. I haven't been going crazy on the infill. Some of that's just laziness, but out of my laziness to not have my 3D prints take up too much time, I found that 20% infill, along with the advantages of that compression of zip tying, has held up pretty well so far. Printing your first layer to confirm a hardware fit. I mentioned that just in terms of hole patterns for mounting things. If you can print the whole pattern layer down first as your first layer of a print, even just a test print, without having to print up the whole thing, you can use that just millimeter thin piece of 3D printed material to test the whole pattern to make sure it matches up. That can be a time saver and save you from wasting plastic. And anticipating that these things are going to fail, right? So again, designing for failure also means printing extra mounts or laser cutting them or however you're making them, having them available to you so that if they're going to fail out on some gig or some installation or whatever you're doing, having extras available is a minimal cost to you and can save you some heartache. If you don't have a 3D printer, no problem. The whole patterns for your mounts or for your motors or solenoids, one quick and easy way to replicate those is to put some masking tape over them and either color in the holes or punch out the holes and then take the tape off and put it onto the item that you want to transfer those holes to so that you can mount your motor. Sometimes that can just be some scrap wood. I've also found that those strong tie construction kind of galvanized steel connectors that you can find at a hardware store. Typically there's like a whole row of just those galvanized steel connectors for connecting up 2x4s together. Those can be really useful and oftentimes already bent in interesting and useful ways. And just taking your whole pattern from your motor or a solenoid and transferring it to those and drilling out those holes can be one way to go if you don't have access to making something custom. Also, I almost went through with sending out the data machines laser cut parts to Panoco, which is a third-party laser cutting service that's, at least in the United States, pretty inexpensive and fast with shipping things to you. I think it was going to be around $40 to have all the different assortments of laser cut mounts printed and shipped to me, or cut and shipped to me. That's one way to get into this quickly without having to spend a lot of time figuring out exactly what you need. Some other things that have come up as I've been developing my bot. is finding that the way I've mounted the motors has a big impact on, no pun intended, on the sound. So raising the beater higher on some of these motor designs so that the stick has a longer time to gather momentum before hitting before striking the drum, makes for a much louder and more natural sounding drum. Early on, I was kind of having the sticks hug the drum as close as possible, and then just finding that the further up I put it, just within range of it being able to strike the drum, made for a much better sound. I know I've said this before, but the idea of embracing the entropy and adjustability and failure of things has been really useful for me, because these moving things will inevitably move in a way that you don't want them to. And thinking like a robot, that was kind of a big breakthrough for me when I was making this design. Was I wanted to make a drum robot machine that would be not a desktop. I see a lot of designs that are kind of desktop or kind of low profile designs, and I wanted something that, from an audience perspective, was going to be kind of something to look at, right? So going vertical for me was a breakthrough, and realizing that I don't have to design for the anatomy of a human drummer. I can have a stack of percussion that is maybe a little bit more interesting, and is the sight line of it allows for a different experience. And all these drums so far have responded pretty well to being on their side or upside down, or however you want to have yours be. But you can break out of the mold of thinking like it has to be around a human form. Yeah. What else? That's it. I got through that relatively quickly, and I'm happy I did. So let's open it up for any questions. If anyone wants to see anything or ask me about a particular design, I'm happy to talk about what I've got going.
Thank you, Donald. That was great. You did have some questions. What kind of printer are you using?
Sure. I'm using a Prusa Mark III. I think I got about 3 or 4 years ago, and it's been holding up pretty well. It's over here. And the filament I've been using on it to print these up has been the Protopasta 100% recycled PETG filament, which is pretty inexpensive and alleviates some of the guilt I have around 3D printing in terms of its recyclability. Yeah.
Well, you got a lot of comments on zip ties, and Sudu shared with us, I guess it's true, that the bay lights are held up with zip ties on the bridge. So.
Yeah, I heard that too. Yeah, I'm a big fan of zip ties. And while I'm here talking about zip ties, there is one. I wonder if I have it. I don't have it with me, but there are some cool ones that have like little mounting holes on them, so that if you need to drill the zip tie into a thing, it's another way to kind of attach zip tied stuff to stuff. But if there was a question there, and I jumped.
Oh, that's good. Ramon said that the springs mounted on the motors are brilliant.
Then that was one I totally stole from Moritz Simon Geist, a German electroacoustic artist who had a video, mostly works with solenoids and miking the solenoids and drum machines, drum bits, and miking the output and reprocessing it. But there was one video he had where he kind of had like a drum and bass groove going with the motors that are clamped to the drums, and I just thought that was such a cool way to do it. And he didn't have to amplify it in any way, right? Because he was just using the existing drums and toms and cymbals.
Well, and you'll have to, I don't know if you were on when Ramon did his piece. He did a really brilliant presentation in Minecraft called Automate Everything with a few pieces. So I'll make sure that you see that. And he's also teaches at UMass Lowell. So you might be a good connect there as well. Loriano Lecant says he's amazed at all the information that you're sharing with us.
Well, I mean, it came to me by other people sharing it, so I'm happy to.
No, it's great. Well, I think also, you know what, Donald, the great thing is, Donald, you come from like an editorial background, so you sort of understand content and how to package it. And so that's very nice. I think people are appreciating that. Did I ask, gosh, I'm getting tired, but did I ask you, let's see. Oh, Lenore from Evil Mad Scientist says, I appreciate all of the techniques suggested from masking tape to CAD. So there you go. Cinetic says, what solenoid /motor controller do you use?
Yeah, that was it's a great question, because that was another process I had to go through. I eventually wound up with a Pololu. The first stab I had at it when I was using just solenoids, I was using the technique that I mentioned that's in the Adafruit Ruiz Brothers, Liz Clark project. And that one's using just a chip, but it was relatively low amperage. So it wasn't great for motors. It was fine for the solenoids because they weren't pulling that much amperage, but the motors do need more power going to them. So I went with a Pololu. Got it here. Here's the design I'm working with. Actually uses a little bit of both. It's sending out, I think four channels to the particular chip that's in the Adafruit project, and then another 4 or 8 channels are going to these Pololu boards. And I got more of them recently. They went on sale. But I went with the Pololu ones just because their voltage was more flexible, and their amperage, they could supply, I think, up to 10 amps or something. These were the TB67H420FTG dual single motor driver carrier. And you can imagine it doesn't roll off the tongue so easily, or my memory. But Pololu has been a pretty great resource for some of these finding exactly the kind of motor driver board that you want for your applications. Oh, Sherry, you're muted. I can't hear you.
Yeah, sorry, because my speaker was going out. Thank you. Suda would like you to post some links, please. And you know, you can also do that in, if you can't do it now, you could do it in Discord.
Sure. I'll see. Let me copy the link real quick to the presentation, and the presentation has links within it.
Oh, great. Thank you.
I'll put that in the chat here.
Someone wrote Ableton. I'm not sure.
Yeah, and that's I am using Ableton Live to drive all of this stuff. Using the Arduino based, or actually it's a CircuitPython based board here from Adafruit. When I plug that into my computer, it comes up as a MIDI object that I can have send or receive signals within Ableton Live, and that's what I use for the piece that's in the show here in the building. You can find the Chachi Jones piece in the door of the. I'm trying to think of the building now.
Which building is Donald in? Hang on, Joe's here. He'll tell us. Which one? Which building is Donald in? Donaldville. What's your project name, Joe? Look it up.
I think it's Chachi's Drumbot.
Chachi's Drumbot. You know, and Donald, did you share with everyone? I know Maker Update is something that they should subscribe to your channel, because Donald actually has been, gosh, have you been doing it like 3 years now?
It's actually going to be, I think, my 5-year anniversary of doing it. Wow. Coming up, I think around August. So yeah.
So you still have a few minutes. Tell us what it is and why we should subscribe.
All right. Well, it's a weekly show where, well, what I used to do at Make Magazine was as a project editor every week, trying to call the internet to figure out all the coolest projects that were happening, to get them ready for either the Make Magazine website or for the magazine itself. I love doing that so much that I went off and started doing that as a weekly video show where I will find the coolest projects and tips and share those every week. it's just something I enjoy doing. It makes me happy to comb the internet every week to find what people are up to and to share that with people. So it's on the DigiKey channel now. So if you find the DigiKey channel on YouTube, you can keep tabs of it every week.
That's great. And Joe said your building is Martineau.
Yes.
And it has a maker update DigiKey banner on top. There are two of those banners on the buildings.
I appreciate that. Thank you for helping me promote.
No, thank you. You've been wonderful. Any other questions for Donald before we move on? And Donald, I'll make sure that you and Ramon get connected. I'll make a note and connect you guys.
Great. And then also, I don't really mention my music so much, but if you search Chachi Jones on Spotify or any of the online music places, you can come across some of my stuff and give it a listen.
Excellent, thank you. I'm going to stop recording. I think